All right, so today we're going to be able to find the volume and surface area of a rectangular prism after changing dimensions. So sounds like a lot. This is pretty intuitive, so we'll just kind of start rolling. Okay. So a box measures 5 inches by 3 inches by 7. Explain whether tripling the length, width, or height of the box would triple the volume. All right, and let's just start looking at what we got here. So first we would find the original volume. So 5 times 3. Remember, volume is just length times width. So we'd end up with 105 inches cubed. Now, if we triple the length, right? Now it was 5. Notice that we would get 15. And we have to put that in for our length. And it looks like our volume actually does triple. I mean, look at it visually. Now we have two extra boxes. Now we have 3 boxes. If we triple the height, same thing. Right? Now we have 3 boxes instead of just 1. So of course it makes sense to triple. Right? Width the same way. Right? Therefore, tripling, multiplying by 3 one side of a rectangular prism also triples the entire volume. Okay? So is this also true for surface area? The answer is no, but let's look at it. All right, so your surface area formula involves addition, and that's really what makes this not work. But we have 2L, 2 length times width plus 2 length times height plus 2 width times height. That covers all 6 faces of our 3D cube, a rectangular prism. So what happens if we triple? Oh, sorry. Let me go back one. Going a little too quick for you. So this would be our initial surface area, right? 142. Well, if we triple the length, we get 130. We get 342. And that is not an actual 3 times as much, right? It's not perfect. It's not a perfect triple. Okay, so you just need to really remember that when you're tripling one side, makes the surface area larger, but does not triple the entire surface area. You're going to have to calculate and take the difference. But if you're tripling and you're looking at volume, very quick and easy, it'll triple the volume, or double or quadruple. All right, if the height of a prism A is increased from 3 feet to 9 feet, what will happen to the volume? So let's see. First of all, we know we're talking about volume. So we're going to have length times width times height. And it looks like we want to take the height, this right here, and make this 3 a 9. All right. So I can tell you that our volume is going to triple. All right, and that's like kind of like with the answers you're going to see on a test. But if we had to prove it, we could say this is our length, our width, and our height. So we would have 2 times 4 times 3. And you would have 8 times 3 is what, 24. Well, my new and improved volume would be 2 times 4 times 3. Sorry, times 9. And that would be 8. That would be 72. All right, and you can see that this is definitely 3 times as much. All right, if the length of a prism A is decreased from 4 to 2, what will happen to the volume? I can tell you the volume would decrease by 1/2, right? Because we went from 4 to 2. All right, and that's more or less like what the answers you're going to be looking at for on a test. All right, the prisms have the same width, same height and width, but different lengths. So how much greater is the surface area of the second prism? All right, this is where you need that surface area formula, where it's 2 length times width plus 2 length times height plus 2 width times height. Okay, and we'll do, let's say, different lengths. So we'll call this the length. This will be the width, and this will be the height. And we just need to do some basic math, right? These aren't tricky formulas. It's just a little bit of legwork. All right, so 2 times the length here would be 5, width would be 2 plus 2 times the length would be 5 plus the height is 3 plus 2 times 2 plus times 3. 2 times 5 is 10, times 2 is 20. 2 times 5 is 10, times 3 is 30. 2 times 2 is 4, plus 3 is 12. That's 62 centimeters squared. All right, and then if we do this one, we will have, let's see, 2 times 10 times 2 plus 2 times 10 times 3 plus 2 times 2 times 3. And again, 2 times 10 is 20, times 2 is 40, 2 times 2 is 20, times 3 is 60, plus 2 times 2 is 4, plus 12 again, and that would equal 112. And then it wants to know the difference. So we just come here, take 112 minus our 62 from it, and we'll get a 50 centimeters squared difference. All right, those are going to be like the longest questions that you'll have on the upcoming test. All right, describe what happens when the volume of the figure is changed by a scale factor. Remember, we always multiply. Scale factor of 13, and the other 2 dimensions stay the same. All right, I can tell you that the volume will get 13 times larger. Think about it, scale factor, multiply, right? Scale factor is 13, and we always multiply. All right, describe what would happen if the figure, if the height is multiplied by a half and all other dimensions stay the same. All right, so we would have to do those 2 formulas again. So surface area, length times width, plus 2 times length times height, plus 2 times width times height. All right, so first, let's see, we got, we're multiplying the height by a half. Well, there would be a difference. Let's see, let's say we're not going to do the math. Let's say the surface area would be smaller, but not exactly 1/2 smaller. All right, and it says to explain your answer, so I think that'll work. All right, we're just gonna leave it there. If you really need help with that surface area problem, go back and just watch that problem again. It's the same every time. Other than that, have a great day. And if you need help, make sure you ask your teacher.